Fire-resistant walls compartmentalize a building to deter the spread of smoke, flames, and toxic gases during a fire. These walls also protect the means of egress to allow building occupants to evacuate safely. For example, using this sketch of a hotel floor plan, if a fire were to start in one of the guest rooms, the fire-resistant walls will slow the spread of smoke and fire to adjacent rooms, the corridor, and the stairwells. Openings in fire resistance rated partitions are protected by fire door assemblies, also called opening protectives, an assembly of products which have been tested and listed for this purpose. These products may come from various manufacturers and may be listed by different test laboratories, but they work together as an important part of a building's passive fire protection system. Each component of a fire door assembly has an important job to do. One weak link could allow the fire to spread. To locate the fire doors in a building, look for the label on the door edge and on the frame. Labels must be visible and legible because they include important information about the assembly, including the rating, the amount of time the door or frame has been tested to withstand fire. For example, a 20-minute door between a corridor and a hotel guest room is designed to provide 20 minutes of protection. By the way, fire doors are usually rated for a shorter time than the walls around them because the amount of combustible material near an operable door would be lower than a wall where furniture and stored items could create a higher fuel load. Codes determine the required rating for all of a building's components and assemblies. A fire door must be closed and latched during a fire in order to perform as designed and tested. If a fire door is propped open, it will allow the smoke and flames to pass through and is of no value. One of the most important components of a fire door assembly is the closing device. A self-closing door has a door closer or spring hinges which close the door each time it is opened. Hold-open devices for fire doors must allow the door to close automatically when smoke is detected. These are called automatic closing doors. A fire door may also have an automatic operator, but the operator must be disabled during a fire, and the door will then become self-closing. The active latch bolt required for fire doors keeps the door closed against the pressure from a fire and the force of water from fire hoses. Door manufacturers require a minimum latch throw for lock sets and latch sets used on fire doors. Unless it is part of a lock set, a deadbolt, which can be held in the retracted position, would not provide a positive latch and therefore cannot be used on a fire door. Panic hardware used on fire doors must be fire exit hardware, which cannot incorporate any mechanical dogging mechanism that would hold the latch retracted. Electric latch retraction may be used on fire exit hardware if tied into the fire alarm system, so the latch would project automatically if there were a fire. Hinges for fire doors must be steel, ball bearing, and of a certain size and quantity. Other types of hinges and pivots are allowed if they are tested and listed for use on a fire door. Spring hinges are allowed for fire doors, but they do not control the door as well as a door closer, and improperly adjusted spring hinges have been a factor in numerous fires. Glazing used in fire door assemblies is tested for its ability to withstand fire. Current codes also require this glazing to be tested for impact resistance. Each piece of glazing must be marked to show that it is certified for impact resistance and for use in a fire door assembly. Traditional wired glass, which was once exempt from impact testing, is very hazardous and is no longer allowed in doors, sidelights, and other areas prone to human impact. Clearances at the head and jambs and at the meeting stiles of pairs is limited to 1/8 inch maximum for wood doors and 3/16 inch maximum for hollow metal doors. The clearance at the bottom of the door must be no more than 3/4 of an inch. Some fire door assemblies are also required to have gasketing at the head and jambs to reduce the amount of smoke infiltration during a fire. Protection plates on fire doors can be installed on the bottom 16 inches of a fire door, but larger plates could affect the performance of the door during a fire. Plates that extend above the 16-inch area must have a label indicating that they are acceptable for use on a fire door. There are also restrictions as to what job site preparations can be made to fire door assemblies in the field. For example, installers are not allowed to drill a hole larger than 1 inch diameter in a fire door, although there is no maximum limit for a hole for a cylinder. To ensure fire door assemblies will perform as designed and tested, they must be inspected after installation, after maintenance, and also annually. A fire door inspector will check to make sure that all of the components are functioning properly, and there are no missing or damaged parts, holes, or modifications that would void the label. If deficiencies are noted, they must be repaired without delay. The inspection report must be made available to the fire marshal during periodic inspections of the facility. NFPA 80, Standard for Fire Doors and Other Opening Protectives, is a standard referenced by the model codes and contains other requirements for fire door assemblies. For more information, visit www.idighardware.com/firedoor. To watch more videos, visit our training page at www.allegion.com/us.